Over the last few days, we've introduced a few new terms all relating to kinematics. Kinematics being the study of motion without regard to what causes that motion. In other words, no forces. First term we introduced was a vector versus a scalar. Who's going to tell me the difference between a vector and a scalar? Remember vector serial versus special K? Here, vector serial versus scalar serial. Scalar has only magnitude. A vector has both magnitude and direction. Good, magnitude and direction. Now, we learned some examples of both vectors and scalars. So you can give me an example of a vector quantity or a scalar quantity. Doesn't matter. Just be prepared to tell me which one it is. Yep. Okay. Displacement is a vector quantity. Good. Give me another one. Again, a vector, a scalar, I don't care. Just tell me which one it is. Sorry? Distance is a what? Good. Distance is a scalar. We don't need direction associated with that. In fact, there shouldn't be a direction associated with that. So distance is a scalar. What else did we talk about? What was the other term that we talked about on the very first day of class? Distance, displacement, and Liam already mentioned it briefly here a second ago. Remember what it was? Not displacement, distance, and what's the other one? Position, right. Is position a vector or a scalar? Good. Position is where you are, right? And of course, where you are, it has to be relative to something. And if it's relative to something, it's going to have a direction associated with it. We learned two more yesterday. What were those two terms that we learned yesterday? Sorry, three more yesterday. One of them was velocity. Was velocity a vector or a scalar? Good. It's a vector quantity. Direction does matter. Two more. One that goes along with velocity. It's almost the same thing, in fact, as velocity. Remember what it was? Speed. Good. Speed is a what? A vector or a scalar? Good. And then the last one I'll give you a hint if you don't remember it. It's the one that we didn't define because we all know what it means. We just couldn't really come up with a good definition for it. This one is the one that I forget all the time. Which one is it? Doesn't. Time, yeah. Time is a vector or a scalar. Sometimes we talk about going back in time, but it's still not a direction per se. It's not a right, left, up, down, forward, backward type of direction. So time is going to be a scalar. Let's go to position first. No, let's go to distance first. Distance was how far something's traveled. Okay, we don't care what direction. The distance between Calgary and Edmonton is about 300 kilometers. Okay, not going to say north, not going to say south, whatever. The distance traveled from Calgary to Edmonton is 300 kilometers. If I go from Calgary to Edmonton and back again, my distance traveled is 600 kilometers. Okay, it doesn't matter that I went north, then south. My position is where I am relative to something. It's got to have a reference point, right? My position in front of the front wall. My position away from Dairy Queen. My position relative to the front doors of the school. Okay, there's got to be a reference point there when you're talking about position, and there's got to be a direction from that reference point. Where you are or where something is. Displacement is the change in position. So if we call distance delta d, and we call position d with a little arrow over it indicating a vector, displacement would be delta d with a little arrow over it. The change in position. Okay, where I am now relative to where I was. How much my position has changed by. And of course, if position is a vector, then displacement's going to be a vector as well. Time, delta t. Speed, how fast something is moving. Velocity, the rate of change of position. Does anybody remember off the top of their heads the equation for speed and velocity? These are on your data sheet if you forget. Yep. Good. Speed is distance over time, so it's going to be delta d over delta t. Okay, it's a scalar, so it's going to be distance over time. Velocity is? Yep. Good. It's displacement over time. It goes right back to the definition, right? The rate of change of position. In other words, the rate at which displacement occurs. What would the typical units be for displacement, distance, or position? We can use other units sometimes, but what are the typical units that we use? If in doubt, always go to these. Yep, meters, good. And what about time? If in doubt, go to, wait a second, nobody can get this? Seconds, yes. And of course, for speed and velocity, it's going to be meters per second, right? Position or displacement over time, meters per second. Is that good? Okay, we looked at some problems yesterday involving speed and velocity. Okay, one of the tricks we ran into here was calculating the displacement, calculating delta D. Sometimes we added things together to get delta D, and sometimes we subtracted things to get delta D. Do you guys remember what the difference was? When did we add two numbers together to get displacement? When did we subtract two numbers to get displacement? I'll give you a couple examples, and I want you to tell me whether we're going to add these two numbers together or subtract these two numbers, okay? Okay, there's my reference point. The wall is my reference point. I'm 2 meters in front of the wall right now. Okay, that's where I am. 2 meters in front of the wall. I'm walking towards the back of the room. Now I'm 8 meters in front of the wall. Am I going to subtract the 2 from the 8, or am I going to add the 2 to the 8 there? Add or subtract? The 2 was what? A position or a displacement? Where I am or how far I've gone? What did that 2 represent? It's a position. It's where I am. The 8 represented where I am now. It's also a position. It's a final position. What do I do with positions? Do I add them or do I subtract them to get displacement? I subtract them. Okay, if you've got two different positions, a final and initial position, like in the example that I just gave you, we're going to subtract those two numbers. Let me give you another one now. Okay, I walk 2 meters. Then I walk 8 meters. Same two numbers, right? 2 and 8. But I was at 2, then I was at 8. Now I'm walking 2 and walking 8. What do I do with those? Add or subtract? Those aren't positions, right? I'm not at 2 meters or at 8 meters. I moved 2 meters and 8 meters. I'm going to add those together. Okay, if you're given a displacement, we'll call it D1, 2 meters, and another displacement, D2, we'll call it 8 meters. We're going to add those together to get the total displacement. Does that make sense? Okay, we've got to be able to do that, right? We've got to be able to do that. When you see two numbers like that, you got to recognize, are these positions, are these where the object is at a specific moment in time, or are these numbers how far the object has traveled? If it's where they are, subtract them. If it's how far they have gone, then add them together to get the total displacement. Once you have that number, displacement, okay, from here or from here, then we're simply going to divide it by the total time. Okay, total displacement divided by the total time. One final question before I give you the worksheet here. Let's say that I'm driving my car towards Banff, okay, which is a couple hundred kilometers away. I'm traveling at 90 kilometers per hour. Okay, once you get into the national park, you got to drive at 90 kilometers per hour, right? That's the speed limit inside the national park. Okay, well, let's say I'm driving 90 kilometers per hour the whole way, but I stop in Canmore for 5 minutes to grab a Big Mac at McDonald's. Literally, just 5 minutes. Okay, it takes me 2 hours and 5 minutes to get to Banff. For 2 hours of that time, I was traveling at 90 kilometers per hour. For 5 minutes of that time, I was stopped. What's my average speed? 45? 0 plus 90 divided by 2? Is it 45 kilometers per hour? No. We don't know what the number is right now, right? But we know that it's going to be a lot closer to what? 0 or 90? It's going to be a lot closer to 90 because I was going 90 for almost the entire trip, right? I was going 0 only for 5 minutes of that trip. We cannot, when we're looking for average velocity, add two numbers up and divide by 2. It's not what we do. If we want to find the average velocity, we need to get the total displacement. Okay, the total displacement between Okotoks and Banff. Divide it by the total time. That gives me my average velocity. Okay, the only time adding up and dividing by 2 ever works is if I was traveling for 2 hours at 90 kilometers per hour and I was stopped for 2 hours, then that would have worked. Okay, but that's not very common that happens. You guys okay with that? All right, I'm going to give you a worksheet that's going to look like this, except you've got some space to work on it. I'm going to give you quite a bit of time here in class to work on it as well. I want you to work really well on it, really diligently, and you got to promise me that you're going to stop me if you're having trouble. Okay, stop me as I'm walking around, call me over, and ask me questions. This is what your quiz is on tomorrow. The whole idea of position, displacement, distance, speed, velocity. So we want to make sure that we're good at this before we have our first quiz tomorrow, okay? All right, I'm going to stop you just for a moment here. Kate just got to number 3 when he was asking me a question. He recognized that he wanted to convert this kilometers per hour to meters per second. I don't want you guys to get stuck on that. I'm going to show you a little trick to convert kilometers per hour to meters per second. We know how to convert kilometers to meters, right? And even hours to seconds is not all that bad. But kilometers per hour to meters per second, how are we going to do that? Well, if you convert kilometers to meters and you can convert hours to seconds, then you can convert kilometers to hour to meters per second because it's just 2 conversions that take place. 90 kilometers per hour is the same as 90,000 meters, right? We're converting kilometers to meters first. 90,000 meters in 90 kilometers, and then there's 3,600 seconds in 1 hour. We get that by multiplying 60 by 60, right? 60 seconds in a minute, 60 minutes in an hour. So you're going to multiply by 1,000 to convert the kilometers to meters, and then the bottom you're going to multiply by 3,600 to convert the hours to seconds. 90,000 divided by 3,600 would give me 25 meters per second there. Does that make sense? Okay, does that make sense? Does that make sense to the rest of you too? Question? How to get 25? Does the 90,000 and the 3,600 make sense? Yeah. Okay, I just divided those 2 numbers. 90,000 divided by 3,600 is going to give me 25. So all you're doing here is 2 different conversions here, right? 90 kilometers to meters, and then 1 hour to seconds. Right? It's the same as 90 kilometers over 1 hour, 90,000 meters over 3,600 seconds. Yep. Yeah, let's not talk about that yet. All right, keep going on the worksheet. You're going to have to do this again somewhere in the worksheet, so call me over if you're having trouble with it, okay? All right, everyone, we're going to take a look at some answers to the front side of the sheet here right now. Number 1, I got in kilometers per hour, 70.0 kilometers per hour. Or if you wanted it in meters per second, it would be 19.4 meters per second. Question 2, I got 1.08 times 10 to the 2 meters, sorry, times 10 to the 12 meters. Or that would be 1.08 times 10 to the 9 kilometers. Number 3, I get 57.5 meters. Number 4, I get 61.3 kilometers per hour, or I got 17 meters per second. By the way, when you see 2 different sets of units here, it doesn't matter which one you have. The only time it actually matters is when I specify. If I said, give me your answer in meters per second, then that's what I expect. If I just ask you for the speed or the velocity, just get it whatever units you want. Any issues with any of those questions, 1 to 4, Jonathan? Yep. Yes, you're right, actually. Yeah, that's a good point. Question 3 is asking us for displacement. Okay, and we know that it is to the north, so we should have written 57.5 meters to the north. And in question 4, in fact, we're looking for the average velocity, which is also a vector. Okay, we know that we went to the north, so that would be to the north as well. Question 1 and 2 are asking us for speed and distance. We don't need direction. Question 3 and 4 asking us for displacement and velocity. We do need a direction. Okay, any questions on those 4 questions? We're all good? All right, have a look at the back side of the sheet then. Take a look at question number 5 on the back of this worksheet now. It says a jogger runs 5 kilometers to the north in 25 minutes, then stops for 10 minutes, then runs 10 kilometers south for 53 minutes. What's the average speed and the average velocity for this runner? We've got 3 things happening here, right? 3 stages, 3 different things. The runner is going 5 kilometers, then the runner stops, then the runner runs 10 kilometers for 53 minutes. 3 different things happening. Let's break it up into stages. Stage 1, stage 2, stage 3. Let's say let's define north as positive. Let's say displacement 1 is 5.0 kilometers. Positive because it's to the north. Time 1 is 25 minutes. Displacement 2 would be what value? In the second stage, how far does this jogger run? 0, right? The jogger stops for a break. So displacement 2 is 0 kilometers. And the time in stage 2 is going to be 10 minutes. And in stage 3, we're going to say the displacement is 10 kilometers. Is that right? Is that right? It's not right. What's wrong with that? The displacement in stage 3 should be negative 10 kilometers, right? Because it's to the south. I define north as positive, south must be negative. My time in stage 3 is going to be 53 minutes. Now, I don't like kilometers and minutes together. I could go kilometers and hours. That makes some sense to me. But I'd rather go meters and seconds. I don't really care which way you go. Okay, whatever way makes most sense to you. I'm going to go kilometers and minutes. That makes this 5,000 meters, and 25 times 60 gives me, I don't know, I don't have that written down. 25 times 60 is 1,500 seconds. This is 0 meters, and 10 times 60 is 600 seconds. This is negative 10,000 meters, and this is 53 minutes. Multiply that by 60, we get 3,180 seconds. So now I'm in meters, I'm in seconds. We could have went kilometers and hours, but to me this makes a little more sense. We want to find the average speed. That's distance over time. The distance that we travel here is 5,000 plus 0 plus 10,000. Notice we haven't put in the negative for the 10,000 because distance is a scalar. The time here is 1,500 seconds plus 600 seconds plus 3,180. That gives us 1.5 times 10 to the 4 meters over 5,280 seconds, which gives me 2.84 meters per second. Had you done that in kilometers per hour, you would have gotten an answer of 10.2 kilometers per hour. Does that question make sense? Distance over time, total distance over total time. Now, let's get the second one, B, the velocity. It's displacement over time. The displacement is 5,000. Notice we're adding these, right? Because these aren't positions. These aren't where the object is. These are how far the object has traveled. 5,000 meters plus 0 meters plus what? 10,000? Is that right? Are we going to end up getting the same thing here? Aren't we going to end up with the same thing here? What's wrong? What have I done wrong? What is it? Yeah, I'm adding. He said subtract. I'm really adding, but I'm adding a negative number, which is the same thing as subtract, right? You got to add the negative value in there because the displacement is to the south, and velocity is a vector here. So we add those together, we get negative 5,000 divided by my time, still 5,280 seconds, gives me negative 0.94 meters per second, or that would be 0.94 meters per second to the south. If I made that in kilometers per hour, I would have got negative 3.4 kilometers per hour. How many people got question A, either in kilometers per hour or meters per second? Okay, not bad. Okay, what about B? Pretty much the same people, I guess. Yeah. Okay, if that makes sense to you now, that's great. Even if it didn't before, that's okay. If it doesn't make sense to you, then make sure you please come and see me. Okay, scheduled help tomorrow, whatever, okay? You guys have great opportunity to see me during scheduled help before quizzes, right? The day of a quiz. So if you're struggling with this still tomorrow, come and see me and I'll help you out with it, okay? I'm going to put up a video here for you right now. It's a movie called Triple X with Vin Diesel. It's how many people have ever seen that movie? Yeah. I haven't seen the whole thing. I don't really care to. It doesn't look like a very good movie. But there's a good scene in there that we're going to show you here right now. It's Vin Diesel coming down, getting dropped out of an airplane, and then snowboarding down a mountain, blasting, causing an avalanche with dynamite, and then he ends up saving the day in the end. Oh, I gave it away. We're going to show you that clip now, and I'm going to have you answer some questions about that clip as we go through the clip. So we'll give you a copy of the handout. Okay, watch the video, and then I want you to kind of, as you go, write down anything you have to write down, and when we're finished showing you that clip, answer all the questions that are on the sheet. Okay, got it? All right.